Completing the square. Key terms. A quadratic equation is a polynomial equation of degree 2. In other words, the highest exponent in a quadratic equation is 2. The standard form of a quadratic equation is y equals ax squared plus bx plus c. A perfect square trinomial is a trinomial formed from the product of a binomial times itself. Take a look at the example below and note how it forms a perfect square. Completing the square is the process of changing a quadratic equation into a perfect square trinomial that can be factored, as in the example you see below. Completing the square. Fill in the blank to make the expression a perfect square in the problem below. We begin by using the standard form. Step 1 is to identify b. We see that b is equal to 8. Step 2, we divide b by 2. Doing so gives us 4. Step 3, square b divided by 2, which we would square 4, and that would give us 16. Step 4, we fill in the blank with our new answer. The perfect square now reads y equals x squared plus 8x plus 16. The purpose of completing the square is to rewrite the following form: the quantity x plus b divided by 2 quantity squared. In the example, you see y equals x squared plus 8x plus 16. We define the b coefficient to be 8. We plug in 8 into the equation and now have the quantity x plus 8 divided by 2 quantity squared. The answer will give us our perfect square of the quantity x plus 4 quantity squared. Example: fill in the blank to make the expression a perfect square. Rewrite as a perfect square trinomial. Step 1 is identifying our coefficient b to be -12. Step 2 is to divide b by 2, so we would take -12 divided by 2. Our answer is -6. Step 3 is to square b over 2, giving us 36. Step 4 is to fill in the blank. G squared minus 12g plus 36. Our answer is now a perfect square, quantity g minus 6 quantity squared. We will now practice completing the square in the following problem. First, we must solve for ax squared plus bx equals -c. We subtract 9 from both sides of our equation. Our new problem reads x squared plus 10x equals -9. Always remember to make sure a is equal to 1. Following this rule, identify b, solve for b over 2, and then square b over 2, which in this case is equal to 25. Now, we must add b over 2 quantity squared to both sides of the equation. We now rewrite the left side of the equation in the form quantity x plus b over 2 quantity squared. Now, we must solve for x. We take the square root of both sides of the equation to get rid of the square. That leaves us with x plus 5 equals plus or minus 4. Subtract 5 from both sides to isolate x. We have to split the plus and minus into two different equations. In the left equation, we have -1. In the right equation, we have -9. Our final answer is -1, -9. What if a is not 1? All we have to do is divide the whole equation by a in order to have a as 1. Once we have that, we can simply repeat the process as the previous question. In the following example, we want to divide every term by 2. We are left with x squared minus 4x equals 5.